This video is going to prove the following fact. If n is a square-free integer, then the number of divisors of n, that's what tau of n represents, is equal to 2 raised to the r, where r is a number of prime divisors. So in case you don't know what a square-free number is, it's a number where no square divides into it evenly. Like the number 32. 4, which is a perfect square, goes into it evenly. 32 is not a square-free number. The number 15 is square-free because 2 squared doesn't go into it. 3 squared, which is 9, doesn't go into it. 4 squared, which is more than 15. No number bigger than 15 will go into 15. So none of the perfect squares go into 15 evenly. This is a square-free number. If you look at the number 80, the squares are 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. If any of these numbers go in, it's not evenly into 80. 80 is not a square-free number. 16 divides 80. 16 goes into it. You probably would have noticed that 4 went in first before 16. Doesn't matter if you can find any number on this list. This is an infinite list that goes into 80 evenly. It's not a square-free number. Okay. So what's happening here is, first, I should ask you guys to subscribe to my channel if you're into seeing mathematical proofs, because that's all we do on this channel is mathematical proofs. Now, if you think about this, the number n can have any prime factors where the power is more than 2. For example, if n was p1 to the first times p2 to the second times p3 to the 1 times p4 to the 3. There are perfect squares that go into this number. If you multiply a number by itself, that's a perfect square, whether that number is prime or not. 9 is not prime. You multiply it by itself, you get 81, which is a perfect square. But we're not going to be in this situation because all our bases are prime. If you take any prime number and multiply it by itself, that number is a perfect square. Also, if you take a prime number, and multiply it by itself 3 times, 3 squared goes in here. 3 squared, 9, goes into 27. It's not a perfect square. This number is a perfect square, and it goes into the product above. It goes in P, this cancels out, and it goes in P1 times P3 times P4 cubed. Also, same number, there's another perfect square that goes into this. P sub 4 squared goes into it. This is a perfect square, and it goes in here P4 times. There's one P4 left over. Possibly you would have preferred maybe that I didn't cross off the P4 but I reduced the power to 1. It goes in there. It goes in this many times. The instant the power is 2 or more, a perfect square will go into that number. So, let n equal p1 to the k1 times pr to the k sub r, where n is square free. I claim all ki's must equal 1. If some k sub I was greater than or equal to 2, that would imply that p sub I squared goes into n. But that's a contradiction, because this is not, it's a perfect square. It's a perfect square. So all p sub I, all k sub i's equal 1, which implies that p, I meant to say n, is just p1 times p2 up to pr. Now, what are the divisors? Well, how many divisors are there? Well, you can pick none of these. That's 0. That's say r. From the r we choose 0. Or you can pick 1 from the r. Or you can pick 2 of them to multiply together. You pick pi times pj. That's not a j. It will definitely divide n. Okay, it will definitely divide n, as long as they're different. Pi times pj, where those are different, will divide n. If I pick 3 of them, r choose 3, all the way up to r choose r. This is what tau of n equals. But you know what? This is nothing more than 2 to the r. Watch one of my other videos and I prove that. Okay, I prove that the summation of r choose k, as k goes from 0 to r, is 2 to the r. And this completes this proof. Once again, if you like seeing mathematical proofs, then you should subscribe to my video. And I do want to just add one thing in this proof. I guess it's clear what r represents. Let's say that. So r equals the number of prime divisors of n. Okay, so I clearly said what this power r really represents. It's the number of prime factors of n. It's the number of prime divisors of n. R is the number of prime divisors of n. See you guys in the next video. Don't ever forget. Keep learning. Watch and learn.